What's up internet, I am Manish from rebellionrider.com. Welcome back once again. In my previous video, we did the data analysis of worldwide COVID-19 data. But today, we will be going a little bit more specific and analyzing country-specific coronavirus data. And here is what you're gonna learn in this tutorial. How to collect data using web scraping. How to fix the bad header of a data frame by giving it proper column names. How to deal with the extra rows and columns. How to fix a value using regular expressions or regex. How to change the data type of an entire column. How to sort the data of a data frame in ascending order. And in the end, how to save this clean data in Microsoft Excel and CSV file. Make sure to watch this video till the end because projects like this could help you build your resume. Anyway, the country whose data I will be using today for the demonstration is no other than my own, India. But you can follow the steps for any other country as the process is the same. Now that being said, let's start the tutorial. But before that, subscribe to my channel if you haven't done so. Also, press the bell icon to get notified. And don't forget to share and like the video. Collect the data. The technique that we will be using for collecting the data is going to be web scraping. Data collection is always the first step for any data processing project. In today's project, data collection is not going to be a problem. Mainly because on my previous video, Mr. Tejas Manik commented saying he was also doing the same project but having errors. He also mentioned the website that he was using. That website is Wikipedia. We will use it as well. The data from this website is not the cleanest, but it looks consistent and it's free for all of us to use, so it fits the bill. Data cleaning. This step is directly dependent on the first step, data collection. So we will see how much we need to clean the data when coding. Data storage. In the end, we will save this data into either Microsoft Excel file or a CSV file. My aim behind doing these tutorials is to show you how easy it is to process the data and make it ready for any type of data analysis. Now that I have showed you the roadmap of this project, let's jump onto the computer and start writing some Python code. And yes, I will leave the link of my GitHub page in the description of this video. From there, you can download all the resources that I will be using in this tutorial, including the Python script that I will be creating in this tutorial. First, let's create a folder which will work as our project directory. I will be creating this folder on my desktop. And I'm going to name it Rebellion Rider. Done. Now let's open up the editor. My choice of editor for this project is again Spider. Now let's create a script and save it into our project directory which we just created. Let's name this script main.py. Let's also set this directory as our console directory. Click here and select Set Console Working Directory. Done. Now let's write the code. Since we are taking data from a website, therefore the technique that we will be using for collecting the data is going to be web scraping. What Python library we will need for web scraping completely depends on the structure of the data. Therefore, we first go to the website. There we will find the COVID-19 specific data. More importantly, we will look for the structure of the coronavirus specific data, and then we decide which Python library best fit our project. So, here we are. Let's search the data that we need. Here is our desired data. So, the data is stored in a table format. The Python library that is the best fit for scraping such data is Python Pandas. Therefore, here we will use the Python Pandas library in combination with the request library. So let's do that. First, let's clean this script by deleting whatever we have in it. Great. Here I just imported two libraries that we are going to use. The first library that I imported is request. The only purpose of this library is to fetch the data from the web page. The second library that I imported here is the pandas. I also gave this import an alias which is pd. Anyways, we are going to use it to do all the heavy lifting. Let's do that. Before I explain you this code, let me quickly execute it. Done. Now, here I created a variable URL into which I saved the URL of the web page that we are using. Next variable that I created is REQ. This is the request variable. It is going to hold the request response returned by the get function of the request library. In simple words, right now this variable is holding the entire data including HTML, CSS and all the metadata of the URL. If you will scroll down a little bit and double click on this attribute text, then you can see the data of the website. Let's close this window. Okay, now we will have to get out the coronavirus data that we need from this attribute, and for that we need its path value, which you can get from here. req.txt is the one that we need. Now let's write the code and get the desired data. Here I call the read underscore HTML function of the pandas library, and as an argument to this function I have passed the path value of the text attribute, the same value that I mentioned earlier. On execution, it will fetch all the desired data and save it into a variable data underscore list. Let's execute this code and see where have we reached. Execution successful. Now let's come to the variable explorer. Here you can see the data type of the variable data underscore list is list. Let's double click on this variable and see what is it holding right now. So right now this variable is holding a list of all the data frames. Each of these data frames contain the data that was saved in a table on the web page that we are saving. From this list, we have to find that one data frame that has the coronavirus data. For you, I have already done that search. The data frame corresponding to index number 6 has our data. Let me show you. Here it is. Now let's get this data frame out from this list. On execution of this statement, data frame against index number 6 will be fetched and saved into a new variable target underscore df. Let's execute this code and see if we have our targeted data separated from the list or not. Execution done. Variable target underscore df is created. Let's open this variable and see what it contains. Finally, we have successfully fetched our desired data. That's how we do the web scraping in just 6 lines of code using Python pandas. Now let's move on to the next step of the data processing, which is data cleaning. Data cleaning is the most important step in data processing. Here we make the data ready for further processing. So take your time and clean your data as much as possible. Anyways, let's take a look at our data frame and see what refinements we need to do with it. Okay, first we need to fix the header of our data frame and give these columns some logical names. Second, in this data frame we have total 9 columns, but we need data only from first 4 columns. Thus, we will get rid of all the extra ones. Third, we will remove some extra rows of data. Let me tell you what am I talking about. Scroll down and come to the end of the data frame. Here, as you can see, we have 2 rows that we need to delete. Let's first fix these 3 shoes and then we will look for others. Okay, let's close this. Great. Now let's write some code. Just a second. Okay. One more thing. Great. Now it's looking much better. Anyways, here I have assigned logical names only to those columns that we need. I have assigned generic names to the rest of the other columns because we will be getting rid of them anyways. Let's execute and see the result. Execution done, and as you can see, we have fixed the header. Now our columns have better names. Right on your screen is the before and after of the data frame. As you can see, it's already looking much better. Now let's fix the next issue, that is the extra columns. The easiest way to fix this issue is to extract all the columns that we need. Let's do that. Here in this statement, I am extracting those 4 columns whose data we need and saving it into the variable target underscore df. On execution, our variable target underscore df will have only our desired data. Let's execute the code and see. Execution done. Now let's check the data frame. Great. Now our data frame is only holding the data that we need. Now let's fix the third issue, that is extra rows from the bottom of our data frame. Let's find out the index number of those 2 rows, 36 and 37. You know what? We cannot simply delete these 2 rows like this. Say you write this statement to drop these 2 rows using their index numbers. First, this is a valid statement. On execution, rows against index number 36 and 37 will be removed. There is no problem with it, unless Wikipedia decides to add some extra rows in between. In that case, this statement will delete rows corresponding to index numbers that we have specified, regardless those index numbers are of last 2 rows that we want to delete or not. So, how we can deal with this problem? Let's assume that the last 2 rows will always going to hold some useless data. In that case, we can fetch the index number of the last row dynamically instead of hard coding it. Let me show you how to do that. Let me first comment this statement. Done. Here, target underscore df is the variable name that has our data frame, and index is the keyword. Followed by it, I have specified -1 inside a square bracket. On execution, this statement will return the index number of the last row of the data frame target underscore df and save it into the variable last underscore idx. Let me execute this statement and show you. Execution done. Here you can see the variable last underscore idx is successfully created, and the value that is stored inside it is 37, which is the index number of the last row. Now we can use this variable to drop the last 2 rows like this. This statement will always drop the last 2 rows of the data frame. You just future-proofed this script by changing a static statement with a dynamic one. See how easy it is? Let's execute this Python program. Done. Now let's see our data frame. Last 2 rows gone. The data frame has already started looking clean. Nevertheless, let's see what else do we need to fix here. As we can see, majority of the values stored into the last 3 columns, total cases, total deaths, and total recoveries, look like integers, but they are actually of string object data type. We can check that like this. As you can see, none of the columns of the data frame has integer data type. So we need to fix that. Let's come back to our data frame first. Great. Though we can easily convert the data type of the last column total recoveries from string object to integer, as every single value in this column compiles with all the norms of being an integer. But same is not true with the rest of the two columns. For example, in column total death, row number 16, we have a value 97C. C is a character and square brackets are a special character which cannot be converted into integer. Similarly, in column total cases, we have a value 52,817B. In this value, comma and square brackets are special characters and B is an alphabetic character which again cannot be changed into integer. Therefore, before converting the data type of these columns, we first need to fix these issues. And to do that, we are going to take help of regular expression. Let me show you how. Let's first fix the alphabetic characters and the square brackets of both these cells, and after that we will deal with the comma. Here I wrote two similar statements, though these statements are similar looking, but they are targeting two different columns. The first statement will remove the unwanted characters from all the values stored in column total cases, whereas the second statement will do the same with all the values stored in column total deaths. Now let's come to the function that I have used in these statements, which is replace. Here I have used replace function of the Pandas library. This function takes two parameters. First one is the old value that you want to replace. The second one is a new value with which you want to replace the old one. In our case, we want to replace all the occurrence of character enclosed within a square bracket with an empty string. To accomplish this, I have taken help from regular expression. The regex that best suits the string that we want to replace is this. This regular expression will search for all the strings that has anything written inside a square bracket regardless of its position. If it finds any such occurrence, then it will replace it with the second argument of the function call, which is an empty string. Just a pair of single quotes, nothing between them, not even a space. Now let's get back to the editor and execute this code. Here we are. Let's run this program once again. Done. Let's check the data frame and see if it has done its work or not. Values are looking good. No more unwanted square brackets or anything. Now let's get rid of this comma. Now to get rid of that comma, let's copy this function call where we targeted the column total cases and modify it. The only thing that we want to change here is the first parameter of the function call. As this time we are targeting the unwanted comma, thus the first parameter is going to be a comma. Second parameter is going to be the same, that is an empty string. Done. Let's execute the code and see the result. Execution done. Let's quickly check the data frame. Comma also gone. Now these columns are all set to get their data type converted. So let's do that. As we want to change the data type of these columns from string objects to integer, thus we will use the to_numeric function of the Python pandas library, like this. Let's close this data frame first. On execution, this statement will change the data type of the column total cases from string to integer. Before I execute the code, let me write the statements for converting the data type of the rest two columns, which are total deaths and total recoveries. Done. Now let's execute the code. Execution is successful. Let's check the dataset. Wow, what just happened here? The data type of the first column is still the same, and we got an extra new column added to our data frame. I must have messed up somewhere. Let's check. Okay, silly me. Python is a case sensitive language. And I misspelled the column name. The name of the column is total cases with capital C. Here I spelled total cases with a small c. Let's change it. Great. Now let's try to execute this code once again. Okay, execution done. Now let's check the data frame. Here we go. Already looking pretty. Here is the before and after of this dataset. Hope you can see the difference. I just noticed that I mistakenly named this column country names, though these are the names of states. Thus, this column should be named states, not country names. So let's change it. Done. Let's execute this code. Now let's check the data frame. Great, now it's correct. Okay, now everything is good with this data set, except that it is sorted using states. Let's sort this data using total cases so that we can see which state is most affected by the coronavirus. Close this window. Great. We can sort the data of any column using sort underscore values function of Python Pandas library, like this. On execution, this function call will sort the data in descending order using the values stored in the column total cases. Let's see. Execution successful. Let's check the data again. As you can see, we have successfully sorted the data in descending order. Comment and let me know where in the list is your state. Now let's get back to the editor and do one last thing, which is exporting the data, and then we will wrap up the tutorial. Now that we have cleaned the data, next we have to save it so that we can further process it. The two most widely used file formats for saving the data are CSV and XLS, the Microsoft Excel file format. You use this format, XLS, for saving the data when your dataset is relatively small, like ours. When you have huge dataset, then you save it as CSV or JSON, or you save it directly into a database. Anyways, let me show you how you can export this dataset in CSV as well as XLS file format. But first, again close this window. Great. Here I have written down two statements. You can use either of those. The first statement will export the dataset into Microsoft Excel format, whereas the second statement will export our data into a CSV format. On execution, this statement will create a file into the project directory where you have saved this Python script. For example, in my case, I have saved this Python script into a folder named Rebellion Rider, which is placed on my desktop. Here it is. Anyways, if I execute this code right now, then a file with the name covid_india.xls or CSV will be created and saved into that folder Rebellion Rider. Let's say I want to export my file in Excel format. Therefore, I will comment the last statement, which is for saving the file in CSV format. Done. Now I will execute this code. Seems like my internet is not working. Let's try to execute this code once again. Okay, my internet stopped working again. It's kind of a usual problem here. Anyways, I will try to run this code again when I have the internet. Okay, I should have internet now. Let's try to run this code. Voila! Execution done. Now let's go to our project directory and see if we have a desired file or not. Here we are. As you can see, here we have our Excel file. That means we have successfully exported our data. That's how we process the data for analysis and analytics. In case if you don't know the difference between analysis and analytics, then I have done a video on it, whose link is on your screen as well as in the description of the video. Anyways, hope you liked the video. If so, then please hit the thumbs up button. Also, share the video with your friends on your social media. Most importantly, subscribe to the channel if you haven't already. Thanks for watching. This is Manish from rebellionwriter.com.